Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for Paper 3-2 May-June 2024. And this is part 1 for questions 1 to 5. Question 1 is coming from modulus functions. And part A, they are saying sketch the graph of y is equal to the modulus of x minus 2a, where a is a positive constant. Here we sketch what we call the V-shaped graphs. So I will first consider y, which is equal to x minus 2a. And then all I need to do is to find the coordinates of the intercepts, okay, where this graph is supposed to be cutting the y and x axes. So if I have x here and then y, if x is 0, that means that one will disappear and then I will get negative 2a, okay? And then next, if y is 0, so put 0 here. Now put this one here, it will be 2a, okay? So I will have here 2a. Now I will draw my axes here. So that is what we are having there. This is y, you label it, and also come here, you label this as x, then this is 0. Then we can have a, then 2a, 3a, 4a, 5a, like that, because they are in terms of a. 0, then negative 2a, 2a. So leave a there. It's a positive constant. Then here I can have a, 2a. I can have 3a here. I can have 4a. It is even optional to put all of these, but we just need these values here. Okay? So we have negative a here, negative 2a, negative 3a. Okay? Then this one will be negative a, then negative 2a, like that. Now, when we draw this one here, 0, negative 2. So 0, negative 2 is here. And then 2a, and then 0 is here. So that means I'm supposed to draw like this. That line is supposed to go like that. Okay? But then, since this is modulus, okay, we are supposed to deal with the positive part of the graph. So this one that goes beyond the x-axis, we actually make it dotted, or you even rub it off completely. Okay, then you reflect it in this x-axis. Now, when we reflect this one in x-axis, here it is cutting y-axis at negative 2. It is supposed to cut y-axis at negative 2a. Now, when I reflect this way, remember the object and the image must be equidistant from the mirror line. The x-axis is the mirror line. Then it will be cutting here. So that means it will be cutting at 2a. So I will get this one and then I reflect it in this x-axis, but it has to be passing through that 2a. So that will be our graph. I can even label this one, and I said this one was already positive for our graph. So we have x minus the 2a, positive. Then this one is the reflected one. Y is equal to negative of x minus 2a. From AS, you know that when you reflect something in x-axis, if this is the coordinate here, and then the one is here, this one is x here, and then this is y here, the x remains the same, but y is going to change the sign, you see? So y has changed the sign. That's why we are writing that one there. So that is going to be our graph. It is optional to label the graphs like that, but it helps you in the solving of, let's say, this part B here. They are saying solve this inequality here. So since they have given us the first one to do the sketch, then I can also sketch this one here, which is given on the same graph, and then I look at the points of intersection, and then I use that for the solution. So we can do it using like 3 methods. Let me use the one of sketching and also splitting, okay? So we can have this y here, which is equal to 2x minus 3a, and then we get the x and y coordinates, the intercepts, okay? So if I have 0 on x, y is going to be negative 3a. And then if I have 0 as y, so take this one here, it will be 3a, then divide by 2, that will be 1.5 of a. Then I come here and then I plot. I have 0, negative 3a, which is here. I'm even going to change the color, okay? Then 1.5 of a 1.5a, that is the x coordinate. So 1.5 has to be in the middle here of a. Now, when I change the color, we are going to have something like this. This other one actually goes beyond the, this one actually goes beyond the what? The x-axis. So for which I will not dot it, or I will not reflect it in the x-axis. Okay? Because for it doesn't have the inequality sign. So I can extend it just like that. So this one here is for y, which is equal to 2x minus 3a. Now, you realize that this graph here is meeting this one that is reflected in here, which is the negative part. It is not meeting this one, which is positive. So when we are solving, we are looking at the intersection of these two graphs above the x-axis. Why is it above the x-axis? Because we have this one as the modulus, which has to be above the x-axis. You see that? Now, we are having this one meeting with this one here. So I'm going to just write, I'm going to consider only two. So one, this one here, the 2x minus 3a is intersecting with the negative of this one here. Okay, remember there is the other method of splitting. So I'm supposed to use this one here and then the other one where we have 2x minus 3a, and then we also say less than, then you consider the positive, because for the modulus it has the positive part and then the negative part. Okay, these two graphs that we are having here, one is positive and then the other one is negative. That's what I mean. Now, here, using my sketch, it is clear that these two graphs, these are the ones that are meeting. This line here is meeting the negative part of the, or the reflected part of the other modulus function. So I then solve this one the same way we solve inequalities. So less than, when I open the brackets, this will be minus x, then plus the 2a. Bring this one this side, collect like terms together. We shall have 2x, then plus the x, less than, take this one this side, it's a minus, so it is going to go there as a plus. So we have 2a, then plus 3a, meaning here we shall have 3 of x less than 5 of a. So our x is therefore going to be less than 5a over 3. That will be the answer. I don't need to do the testing here because already I've sketched this one on the same graph and it has shown me that this graph is meeting the reflected part of this. So when you do the sketching, you don't have to test. Question 2, express this expression here in partial fractions. Now, before you even go any further, the fact that they have told us to express it in partial fractions, that means the denominator here must be factorizable. Okay, it must be factorizable. Now, let's factorize the denominator here and we see. We can put this in the calculator to simplify the work. So you come here, you press mod, then equation is 5, then quadratic is 3, and then we can press 2, that's the coefficient of x squared, equals, then negative 5, then equals negative 12. Then this one gives us 4, and then negative 3 over 2. So I can write x is equal to 4, and then x is equal to negative 3 over 2. So when I bring this one back here, it will give me x minus 4. Cross multiply here, you get 2x, then bring that one back here, you get this one here, 2x plus 3. Now, we can keep that one somewhere. Let me just keep this one somewhere. Also look at the degree of the numerator and the degree of the denominator. The degree is that highest power of that variable. So this is a 2, this is a 2. They are all of degree 2. That means this is an improper fraction. So you have to first divide it such that you get a proper fraction. So we use long division. Okay, so we are going to have 6x squared minus 9x, then minus 16. And then here you have 2x squared minus 5x minus 2. It should be noted that if the degree of the numerator is greater or equal to the degree of the denominator, you first long divide, okay, to get a proper fraction. Now, when we are long dividing, get the first, you divide by the first, the rest you multiply. So 6x squared divided by 2x squared, you will get 3. Then the rest, I'm going to get this and multiply by the 3. So I'm going to have 6x squared, then negative 5 times 3, that is negative 15 of x, and then negative 12 times this negative 3, 3, you'll get minus 36. So when I subtract, of course, the 6x squared will disappear. Now negative 9 minus 15. This one will become a plus. So that means what we get there will be 15 minus 9. 15 minus 9 is the same as 6. So I'll have here 6 of x, then minus negative 36 minus 36. That's the same as saying 36 minus 16, which is a positive 20. So we shall have positive 20 here. Now, this therefore implies that since the power of x here is smaller than the degree here, then that means we are going to stop there because we cannot divide anymore. It's like when you are dividing 7 divided by 3, and then you get a 2, then there is a remainder. So you just write that one there, remainder 1. So you write 1 over the 3. So you cannot divide this anymore. Okay? So this is the same thing that we are going to have here. So we shall write this one as 6x squared minus 9x, then minus 16 out of 2x squared minus 5x, then minus 12. This one is the same as 3, then plus. The remainder is 6x plus 20, but I'm going to write this one here as this, okay? So I'm going to write x minus 4, then 2x plus 3. Now I'm going to reduce this one to the partial fractions, okay? So this one here, let me just copy it and then just put it here. This one is going to be equal to a out of x minus 4. We have only linear factors, so plus b out of 2x plus 3, okay? Now here, the LCM is going to be this one. So this one here, divide by x minus 4, you'll get the 2x plus 3, then times the a, okay? So, in fact, not to waste time, you just multiply this and this, then this and that, okay? So we have a into 2x plus 3, then plus b into x minus 4. Then this one will be equal to the numerator we have there as 6x plus 20. Now I look out for x values when I substitute them in here, okay? Like one value I substitute it here, it makes this one disappear, and then I remain with only this one. So that will give me the value of a, okay? So suppose our x is equal to 4, okay? Suppose the x is equal to 4. Now, what are we getting here? 4 times 2, that is 8, plus 3, that is 11. So 11 of a is equal to, this one will be 24, then plus 20, that will be 44. So 44 here. Meaning when we divide all through by 11, our a is going to be equal to 4. Then how about x being equal to negative 3 over 2? You just get this one equal to 0. So the value of x you get there is the one that you're going to use. That is negative 3 over 2. Of course, this one will disappear. And then here you will have negative 1.5 minus 4. That will be negative 5.5, which is the same as negative 11 over 2, okay, of b. Then this one will be equivalent to, put it here, negative 1.5 times 6. 1.5 times 6, that one gives us 9. So this will be negative 9, then plus 20, that one will give us 11, okay? So that will give us 11. So meaning we can cross multiply here. Of course, 11 will disappear, and then our b will become a negative 2, okay? Our b will become a negative 2. So meaning that our expression which we are given here, okay, let me just get this one here, and then I copy it, just put it down here. So our expression here remember it is equivalent to 3. We wrote a 3, then plus the a is a 4 out of x minus 4, and then our b is a negative 2, then out of the 2x plus 3. So this is going to be our answer. Question 3. The variables x and y satisfy the equation a power 2y minus 1, which is equal to b power x minus y, where a and b are constants. Part A. Show that the graph of y against x is a straight line. It has to be in the format y is equal to mx plus what? Plus c. Okay. Now, what we are going to do here is to introduce logarithms on both sides. There are two ways I can do this. I can first use the rules of indices, then after I introduce logarithms, or I can introduce logarithms straight away. Okay, so let's see. If I introduce logarithms straight away, so this will be natural log of a, then power 2y minus 1, then this will be equal to the natural log of b power x minus y. Okay, using the rules of indices, this one can come down here, and also this one can come down here. Okay, so we can have our 2y here minus 1. You put this one in bracket because there are two terms that are going to multiply with this natural log of a. And then here we shall have x minus y, then the natural log of b. Now you can open the brackets. So 2y times natural log of a, you will get 2y natural log of a, then minus, because you have negative 1 times this one. So you will get minus natural log of a. This way we shall have x natural log of b, then minus y natural log of b. Okay. Now we are supposed to make y the subject of the formula. So put those that have gotten y onto one side. So we shall have 2 natural log of a, then plus the natural log of b. Then I can put these ones in brackets. Okay. And then I put y outside. This one has come this side. Okay. And it has become a plus. But then I've factorized out the y because it is common. It is here and it is also in this one here. Is that clear? Okay, then next, take this one, this other side. So we shall have x, then natural log of b, then minus. This will be a plus, natural log of a, because when this one crosses, it becomes a plus. So meaning our y is therefore going to be equal to natural log of b divided by 2 natural log of a, 2 natural log of a, then plus the natural log of b. All of this is multiplying x. In other words, I'm just dividing all through by this. Okay. So we shall have plus, then natural log of a out of 2 natural log of a plus natural log of b. Like that. Okay. In fact, I can simplify it and I say, using the rules of indices, logarithms, this is natural log of b. Then here I'll have this one coming up here. It will be natural log of a squared. Then after that, because this is addition, then they are going to multiply. Okay. So altogether I can write natural log of a squared, then times b. Okay. Then here x, and then plus natural log of a out of natural log of a squared, then times b. So this is what we are going to have here. It is in the format y is equal to mx plus c. So meaning your gradient is this one here. And then the c, the y-intercept, is this one here. Okay. Alternatively, we can do it this way. Alternatively, we can use the rules of indices. Okay. The rules of indices, this one here is the same as saying a power 2y, then divide by a power 1. Because you know that if I have a power b over a power c, then this one is a power b minus c. Not so? So that means this one goes down and it has power 1 because here we are having minus 1. Then this one will be equal to b, then power x out of b power y. Then I can cross multiply such that I have y on one side. So a power 2y, then times b power y. This one will be equal to a, then b power x. Now in indices, we have a rule that if you have x power y times, let's say z power y this is the same as saying xz, then power y. So it is what I'm going to use here. This is a squared, okay? Then times b, then all of them are power y. You also know that a power b power c is the same as saying a power b times c, okay? So the a power 2y is the same as saying a power 2, then power y. You see that? So that's why I've left this one as a squared, okay? So I can take all of this off. And then this one is equal to a power b x here. Now we can introduce the logarithms. So introducing logarithms, we can have natural log of a squared b, then y here is equal to the natural log of a b power x. Now this one can come down here, and then we have y natural log of a squared of b, okay? Then this one is equivalent to, since this is a multiplication of two terms, in logarithms it comes from addition of logarithms. So natural log of a, then plus the natural log of b power x. Again, this one can come down here, okay? So meaning we have y natural log of a squared b. Then this one is equal to, let me even write this one first, okay? X, then natural log of b, then plus the natural log of a. So meaning y is going to be equal to natural log of b out of natural log of a squared b, then times the x, okay? Then plus natural log of a out of natural log of a squared b, like that. So please, you don't cross this a with this one, huh? No, it just remains there like that. Some people are funny in their conclusions. So you can see that this is the same as what we got here. Part B, given that a is equal to b cubed, state the equation of the straight line in the form y is equal to px plus q, where p and q are rational numbers in their simplest form. Rational numbers are numbers that can be written as fractions. Now we have y, which is equal to natural log of b over natural log of a squared of b, and then x, then plus the natural log of a out of natural log of a squared of b, okay? But then we are given that a is equal to b cubed. So wherever there is a, you just put b cubed. So we shall have natural log of b, then divide by, this will be natural log of b cubed, then it is squared, then times the b here, okay? Remember, this whole thing is in that natural log, okay? In fact, let me write it better. We say like this, then b cubed, you square it, then after times b, you see? Then times x, then here this will be natural log of b cubed, where there is a, remember we are putting b cubed, then natural log of b cubed again, squared, then times the b here. So y here is going to be natural log of b. Down here it is going to be b power 6 times b power 1, that is b power 7. So we have natural log of b power 7. And then here we shall have natural log of b power 3 over natural log of b power 7. Now, using the rules of logarithms, this one can come down here. So we can have y, which is equal to natural log of b, then divide by, this is natural log of b, divide by 7 natural log of b, then times x. Then plus, this will be 3 natural log of b, divide by 7, then natural log of b. So do you see that this one can cancel with this, then also this with that? So that means we are going to have our answer as y, which is equal to 1 over 7 of x, then plus 3 over 7. Do you see that the p is a rational number? It is this 1 over 7, and then q is this 3 over 7. They are fractions, and in their simplest form, so that is that. Question 4. The equation of a curve is given by this. Then find the gradient of the curve at the point where y is equal to 1. Now, for y is equal to 1, for y is equal to 1. We need to get the value of x because we are going to substitute in our dy dx, which is going to be in terms of x and y. So we need first to get the value of x when y is equal to 1. So this will be e to the power of 2x, then plus e to the power of x, which is equal to 6. So I can bring the 6 here is equal to 0. This is actually a quadratic in e to the power of x because e to the power of 2x is the same as e power x then squared then plus e power x minus 6, which is equal to 0. Okay, this is a quadratic in e to the power of x. Now, two numbers, when I multiply them, they give me -6, but then when I add them, they give me 1. Automatically, those ones have to be 3 and -2. So meaning I'll have e to the power of x, then plus 3, because it's positive, and then e to the power of x minus the 2, which is equal to 0. So meaning e to the power of x is going to be equal to a -3. Of course, this is undefined, okay? There is no number you're going to power with this e, and then it ends in a negative. That's why we don't have logarithms of negative numbers. And you know that logarithm is the power to which a number must be raised to give a certain value, okay? Then e to the power of x here can be equal to 2. So we can take this one here, okay? We can say x is equal to natural log of 2, or we can first leave it there. Now, to find a gradient, we need to differentiate, because differentiation is the process of finding the gradient of a curve. Now, this one is a product of two functions, so I'm going to use the product rule. Even here, I'm going to use the product rule. So using the product rule, I'm going to have y, we keep it constant, then we differentiate with respect to x this e to the power of 2x. Then from there, we can keep this e to the power of 2x constant, and then we differentiate y with respect to x. Then we can go to this one, plus. Now keep y squared constant, differentiate e to the power of x, and then plus. Now keep this e to the power of x constant, and then you differentiate this y squared with respect to x. Then this one will give us a 0 when you differentiate this 6. Now, when we differentiate an exponential function, e to the power of f of x, we actually get the power, we differentiate it, so it is f prime of x, then we multiply by e to the power of f of x, okay? So meaning when we differentiate here, we get a 2, then times all through, we shall have 2y, then e to the power of 2x. And then when you differentiate y, since this one is also variable, we are going to differentiate that y with respect to y, okay? But then after, we shall multiply by dy dx such that this one can cancel with this, and then you remain with the d of y dx. You see that? So when we are differentiating, this is what we call implicit differentiation. So when you differentiate y with respect to y, you get a 1. So we shall have plus e to the power of 2x, then times 1, then dy dx. Then here, same thing, of course, when you differentiate this one, you get a 1. So 1 times all through, we shall have y squared, then e power x. And then here plus, when you differentiate this one, you get 2y. So we shall get e to the power of x, then times 2y, then dy dx, which is equal to what? 0. Then you factorize out the dy dx. So we shall have e to the power of 2x, then plus 2y e to the power of x, and then we have dy dx here, okay? So I've put this and this together. That means I can take this one and this one, this other side. So all are going to be negative, okay? So I will just write negative of 2y e power 2x, then plus y squared e power x. So that means our dy dx is going to be equal to, I can pull out the e to the power of x, which is common. Remember, e to the power of 2x is the same as saying e to the power of x, then squared. So When I pull out 1, then that means that here I'm remaining with 1 e to the power of x. Then here plus y squared. Then we divide by this one here, but also e to the power of x is common. So I can have e to the power of x, then plus 2y. Okay, so this one will disappear. Now from there, remember we have our y, which is equal to 1. Was it 1? Yes, y is equal to 1. And then we got our e power x. So y is equal to 1, and then e power x, we got it as 2 here. Okay, now we can substitute. This is negative of 2 times y is 1. Okay, then times e to the power of x is a 2, so times 2, then plus 1 squared, then divide by, this one will be 2, then plus 2 times 1. Okay, now simplifying this is going to give us, this is a 4 plus 1, that will be a 5. So negative 5, then over a 4 down here. So our answer is negative 5 over 4. Question 5 part A, they are saying that it is given that the equation, this one here, has only one root. Show by calculation that this root lies in this interval. So what you can do is to put everything on one side. I can take this one here, or I can take this one here. Okay, so these are two equations. We can even use the graphical. You sketch one graph and then you sketch the other. If they meet at one point, then that means that there is only one root. Okay, it is the intersection of the two graphs. Now when we are using this one, we put all of these onto one side and then we get a function. Okay, so I can have e to the power of 2x, then minus 5, then minus cos of 3x, which is equal to 0. A root is that value you are going to substitute in the function and it reduces it to 0. So meaning our function here, I can let it be f of x is going to be e to the power of 2x, then minus 5 minus cos of 3x. Okay, now I can substitute this 0.7. If this is my function and it crosses maybe x-axis, because that is where it meets x-axis, that is the root. This is the x-axis. So we can get a value on the left of that root and the value on the right of that root. Okay, let's say this one is 0.7 and this is 0.8. So when I substitute in here, okay, the value of y here will correspond to a y value that is positive. It is above x-axis, and then here the y value will correspond to a value that is below x-axis, so it is going to be a negative. So meaning that if we have two values, one is on the left and the other one is on the right, when we substitute their values in the function, we should get different values. We should get different signs. Okay, there has to be change of signs. So this one here, I'm just giving an example. I don't know whether when I put 0.7, I get a negative, and when I put, I get a positive, or when I put this one, I get whatever. So it's just an example. So wherever a curve is meeting x-axis, that point where it crosses the x-axis is the root of that equation. Are we together? Then on the left of it, the function is going to have a certain sign, and also on the right of that root, the function is going to have a different sign from the other one that you found at first. So substitute in here, you get e to the power of 2 times 0.7, then minus 5, then minus cosine of 3, 0.7. And when you substitute this one, since we have a trigonometric function in there, you must put your calculator in radians. So how about 0.8? So we shall have e to the power of 2 times 0.8, then minus 5, then minus cosine of 3 times 0.8. Now here, I brought these to this side to become minus. But it is also possible that you can take this one, this side. So you have 5, then plus cos of 3x, then minus e to the power of x, and then you take this one as your function. No problem. All are marked correct. So you just choose the one that is simpler for you. Now putting in the calculator, when it is in radians, what do we get? So my calculator here is in degrees, so I will press shift, then mod, and then rad is 4, so it is now in radians. Now I can press shift, then the natural log, then this e to the power comes, so this is 2, then times 0.7, and then down here I have minus 5, then minus the cosine of 3, then times 0.7, like that. So we get negative 0.43995 and the rest of those figures, okay? Negative 0.43995. I'll stop there. There are other figures. So how about when we put 0.8? So wherever there is 0.7, I'm just going to change it to 0.8. Okay, even here, 0.8. This one is positive. The other one was negative. This one is positive. 0.69, 0.690426, and the rest of those figures. Then you can conclude that since, okay, you can conclude and say since there is a sign change, between f of 0.7 and f of 0.8, comma, the root lies in between 0.7 and 0.8. 0.7 less than x less than 0.8. As simple as that. Part B, show that if a sequence of values in the interval, this one given by the iterative formula, this one converges, then it converges to the root of the equation in part A. You just need to rearrange this one that is given to get what is in part A here. Rearrange this to get this one here, okay? So you drop the ends. So we shall have x, which is equal to a half natural log of 5 plus the cosine of 3 of x. So cross multiply, you will get 2x here, which is equal to the natural log of 5, then plus cos of 3x. Now, of course, to undo the logarithm, we use exponentials. So we shall have e to the power of 2 of x, which is equal to 5, then plus cos of 3x. So it's exactly what we are having here. So therefore it converges. By the way, when we are looking for the iterative formula, we either make this x the subject of the formula or this one here. In these numerical methods, this is the method that we can use to solve equations which cannot be solved using the usual algebraic methods. Okay, so x is represented in terms of, again, x. So we are supposed to make this x the subject of the formula or this one here. Now, when we do so, one of those is going to converge and the other is going to diverge. Okay, so what do we mean by converging? When you iterate, you see that values are concordant or they are similar. Okay, and then you will get maybe to 2 decimal places, you find that they give the same value. But then the ones which the other one which is converging, you can put in the iterative formula, you get a value. Then the next one you get is not actually related to the one that you have gotten. They are far different from each other. Okay, so the one that they usually give you here to prove that it converges, it is actually the one that converges. Okay, so that is that. Alternatively, you can use this one here and you make one of them the subject of the formula, but it comes to this one here. Okay, so I can actually make this x here the subject of the formula. So we can have introduce logarithms on both sides. Natural log of 2x, then natural log of 5, then plus the cosine of 3x. Using the rules of logarithms, this one can come down here. Then we shall have 2x, then natural log of e, which is 1, then will be equal to the natural log of 5, then plus cos of 3 of x. And then we can divide all through by 2, so meaning x is going to be a half, the natural log of 5, then plus cosine of 3 of x. So you see that what we have gotten out here is what is given here, okay? N just represents the number of iterations that we are going to be dealing with. Then part C, use this iterative formula to determine the root correct to 3 decimal places. Give the result of each iteration to 5 decimal places. Since in part A, we saw that the root lies between 0.7 and 0.8, our initial approximation, we can get the average of the two. I always recommend that you let your initial approximation be the average of those two. So but you can use your initial approximation as 0.7, you can use 0.8, whichever you want, okay? So let the initial approximation be x1, which is going to be equal to, we have 0.7 plus the 0.8, then we divide by 2, this one is 0.75. Then we substitute in the iterative, formula here. So we have it as x n plus 1. So our x2 is going to be equal to a half, then the natural log of 5 plus the cosine of 3, then 0.75. So we put this in the calculator and then we see what we get, but we write the result to 5 decimal places. And since we are having a trigonometric expression here, then we are supposed to put our calculator in radians. I always write it here, calc in radians, so that you don't forget. So the moment you reach here in numerical methods and you see a trigonometric function, turn your calculator to radians. So already in part A, my calculator is in radians. So I'm going to put here a half, 1 over 2, then the natural log of 5 plus the cosine of 3 times the 0.75, then close that. This is 0.73759, 0.73759. Okay, then x3, what is it going to be? It's a half. I don't need actually to substitute. You show the examiner that you have substituted the first one. So don't waste time again showing a half, natural log of what? No. So just put this one here. Don't press answer. Okay? That you say a half, then natural log. So when you are substituting and then you say answer, no. You just put this value in the place of this. Okay? Because when you press answer, you might not get the same answer finally. You might get it, but sometimes it fails. Okay? Now we are going to put this 0.7375759. What do we get? That is 74094. 0.74094. And then x4 is going to be, now we substitute this one here. We shall put 74094. That is 0.74003. 0.740, then another 0 and 3. Then let's check out another one here. 0.74003, like that. So we get 0.74028. 0.740, okay, 28. This one here, when we round off to 3 decimal places, it gives us 0.741. We are going to add on another one here because these two are the ones that are giving us 0.740. So the next one is now going to be, so we put in 0.740, then 28. That one is 74021. 0.74021. Now these three are giving us the 0.740 to 3 significant, to 3 decimal places. So that means the root here, the x is going to be equal to 0.740. to 3 decimal places. Okay, so that is that. Now we are taking these 3 values because these 3 have to be giving you the degree of accuracy here. If you get 2 values that are giving you the required answer to the required degree of accuracy, that means you need to go one more, because you can get these 2, yes, they are giving you that answer, they are rounding off to the same value, but then the third one, when you put in, it can fail, and then it goes to the third one. So that means the minimum number of iterations that you're supposed to carry out, that is where you have 2 values, the last 2 values, when they are giving the same answer to the degree of accuracy they have told you. You see that? So meaning the third one or the next one that you put is the one that is supposed to confirm. So like the third one here we have put is the one that is confirming, because all of the 3 are giving 0.740. So our answer is therefore that 0.740. So this has been it for this first part of this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.